Yeah, well, welcome. Thanks for coming. Yeah, I'm here to talk about, is this me breathing? Yes. Well, I guess welcome to NIWeek. Is that doing anything?
Yeah, a little bit.
Okay, how's the volume in the back? Thumbs up? Okay, cool. That's me. I'm Ethan Stern. As John said, I'm a managing partner of Compose Systems. I'm a CLA, embedded developer, CPI. I like to teach Core 1 and Core 2. I'd love to teach that actor framework class someday. Alan never stops.
Come take it and we'll talk.
Okay.
That's the deal. You got to do CPI, you got to take the class.
Oh,
Yeah.
good to know.
I can't do that anymore.
So, about me, I'm really into solid software, which is about the nerdiest thing in the world you can possibly say. So, you know I'm a total geek. Tested software. We try to eat our own cooking and not just talk about unit testing, but do it on our projects and on our frameworks and things like that. Agile principles. We value Scrum. I'm not saying we use it all the time, but it's something that's important to us. Craftsmanship. I'm here today talking about this stuff because it's exciting for me to work on it, and I like to share it. I would love to field questions and have people come up and talk to me. If you get excited about actor-oriented design, we should probably talk, because I do too, oddly enough. And then a lot of my vocabulary over the past few years and my outlook on life and on the world has been influenced by the writings of Nassim Taleb, and most people know him as the guy who wrote the book The Black Swan, but he's written a whole series of books talking about complexity and having a healthy respect for complex systems, how tinkering and doing is the root of all knowledge, fragility and robustness. He has a book called Anti-Fragile, which is just absolutely mind-blowingly cool. And his latest work is Skin in the Game, and I'm trying to have skin in the game, and I think without even trying, I have what he calls soul in the game, because this stuff is really important to me. So there we are. Now you know a little bit about me. All right, so this presentation is really about my delving into the world of separation of concerns design patterns. If you've heard of Model View Controller and tinkered with it, or used it, or written one yourself, then you know what I'm talking about. And if you haven't, then stay tuned. All right. So before we begin, let's just clarify a tiny bit of terminology. The actor framework is a framework. It doesn't solve domain-specific problems. Right? It is a tool that is built on design patterns, like the command pattern, an object-oriented design pattern. And what I'm talking about, while it adds a lot on top of the actor framework, for better or for worse, it's still just a framework. It's not designed or intended to solve application-specific problems. Right? I don't care about your pumps and valves or your robot arm or any of that stuff. I care about, when I'm writing this thing, when I was writing it, I was writing it to solve the majority of problems that we commonly have to deal with at Compose Systems, based on what I've learned about solid design principles and the abstractions that I kept rewriting from one job to the next, and then having these little epiphanies like, oh wow, if I took that cool thing and I merged it with this idea, and I sort of backed my way into separation of concerns, read up on it, and realized, oh yeah, why don't I just write that? Okay, so my starting point was the actor framework. I thought long and hard about how much of this project should be based on the actor framework and how much of it should be written from scratch. And I settled on basically entirely using the actor framework as the underlying building block, because I know it, I'm comfortable with it, it's robust, it's supported by NI, and when Alan and I were talking at the CLA Summit, I learned it's tested also. Right? There are unit tests for the actor framework. So all good things. It's an implementation of the command pattern with a lot of other stuff. there is an API for how actors behave. I want to handle errors, I override handle error. I want to do stuff before my actor launches, I override pre-launch init. Those things are not part of the command pattern, they're extensions to the command pattern. And they're basically opening an interface to how do I use and deal with and launch and shut down actors. Right? Great starting point for what I want to do, because now that I use the actor framework a lot, I just deconstruct problems in actor-oriented ways. I think about asynchronous coding when I'm thinking about solving a problem. And so actors come with contracts between each other, right? When I launch an actor, it automatically gives its nested or its launchy or its deputy or whatever word you want to use. What are we using these days?
So actor framework is still at caller and nested.
Okay.
Future actor-oriented frameworks may use different names.
All right. So when I'm launching a nested actor, that process of calling the launch nested actor automatically gives that nested actor the launcher's queue reference. So now they can talk to each other, right? So I get a lot out of the box. Messaging, right? The message scripting, it's all built into the IDE. Super helpful. But for me, it still doesn't solve problems that I end up rewriting over and over again, having to do with user interface and these messaging scenarios that Alan was talking about in his presentation, where actors maybe want to traverse the tree and maybe they don't want to traverse the tree because it's a lot of messaging, or in my opinion, traversing the tree makes my application harder. I don't want to say harder to debug. There's sort of an asterisk on that one. It's a lot of code. Right? People don't like having 3,000 message classes or 200 message classes in their project. So it tends to become a pain point, for better or worse, in actor-oriented design when you don't start thinking like Alan is, with finding basically shortcuts or things that maybe compromise type safety a little bit, but save you from having to do a ton of work. There are some compromises there that maybe we're mostly willing to make. All right, so I think there are some things this doesn't solve. Well, I know there are, right? Because we can't just run the active framework and our test system works correctly. All right, so I'm stacking the observer pattern, which is publish, subscribe, essentially, onto the actor framework. And Alan was just talking about this. Where I'm launching a mediator actor, and things like analog input can publish data to the mediator, and data analysis can subscribe. Right? Simple idea. Think of an air traffic control at an airport. Right? The planes aren't negotiating among themselves who lands first. There's a central controller receiving the information and distributing it to everyone. It's a basic idea. In the observer pattern, actors can publish, they can subscribe. The mediator's job is to host the data. Keep in mind, it can be a really helpful debug tool, which is something that the framework I'm going to show you takes advantage of. If I have a central place that all of my global data are streaming through, I can just look at it. So what is separation of concerns? There are a lot of different versions of this. People like to argue about them. I don't want to argue about them here, maybe later. But model view controller, model view ViewModel, not a typo. And plenty of developers have gotten tired enough about arguing that they just say MV whatever. Right? It doesn't much matter. There are nuanced differences between these patterns. The basic idea is the same, largely the same between them, where models do business logic. Views are the things you look at. And the controller or view model is the place where the magical coupling happens, while letting these two domains of visible stuff that maybe has buttons and charts and indicators interacts with business stuff. Everyone I've ever talked to about this has been very enamored with the idea of separation of concerns, but I've seen a lot of clumsy implementations. I've written some myself, and I think I finally learned how to do it right. Who here has heard of MVC, Model View, ViewModel? Okay. Who here has tried writing it themselves or written it themselves? Cool. All right. So taking that simple launch tree, I probably should have mentioned that several slides ago when I was showing bubbles with arrows pointing to each other, and just assuming that this audience probably gets that. I was trying to represent not inheritance, but the launching of actors, right? So here we have a view model, this top-level controller of my application, launching sub-hierarchies of models that do business and views, right? I've tried to stick with the same metaphors here, right? Having the same business actors as I had in the previous example, and you might say, well, this seems like it's going in the wrong direction because I'm adding more actors, and that seems like it would probably be complexity. Don't worry about adding actors if they're there for the right reason. I've written plenty of applications that launch hundreds of actors at the same time, and they work perfectly well, in fact, better than applications that try to thread everything through one pipeline. Okay. Your view hierarchy, we'll get more into what that might look like soon, might start deconstructing your user interface into small, little compositional blocks that can be rearranged and populated, either dynamically or statically or some hybrid thereof. Okay? So models do work, they manage state, asterisk on that one. The more state you can take out of your classes, the happier you'll be. They publish, they subscribe. It makes sense that something acquiring data would need to publish it to listeners. Maybe no one cares, but maybe you just want to serve that data somewhere in case someone wants to read it. They also need to subscribe. If I'm doing concrete test steps and I launch a step, it might need some data, right? It needs some data to do some concrete work. So models can read and write. Views display. We try to keep them as thin and as passive as we can because life is better that way. They can generate events because they have buttons on them, right? I'm not saying controls and indicators can't commingle. I'm saying things that do business logic and control safety valves and move motors don't belong in user interfaces. And it's also tempting in Labview to just start implementing code behind your UI because you can, and because every single VI you create in current gen Labview has a front panel and a diagram. All right, so there's a general guideline for object-oriented design to favor composition over inheritance. Inheritance would be when I have a user interface and I say, oh, I like that user interface, but I need to modify it a little bit, so I'll create a child of it. Well, in actor land, our user interface is actorcore.vi. And if I want to create a new actor that inherits from the parent actor, I have to create a whole new user interface. Meaning I'm not taking advantage so much of that inheritance, well, totally not using inheritance as far as UIs are concerned. I'm just overriding, right? I have to rewrite it from scratch. Maybe I copy and paste or do a save as or something. It's still pretty clumsy. There's a lot of code I'm writing and maintaining and debugging that I probably don't need to. So my point is, why don't we apply compositional design to user interfaces? We have all the tools. Let me show you. And the reasons why we use composition in general is that it's less rigid. If I write something that works really well and it's unit tested and I want to use it somewhere else, I just use it somewhere else. I don't have to worry about who it descends from. And so I end up building building blocks that I can reassemble in different ways, and you'll see some places that I do that in the framework. Right? And then I'm just trying to tease you a little bit. When you do all these things, and you define what a viewable is and how it can interact with the world, what a model is and how it can interact with the world, and a view model that manages the relationship between them, and a mediator, all of a sudden really cool possibilities open up. And I've just kind of discovered a lot of this stuff as I was writing and designing. All right, so in this new way of thinking, we have a ViewModel who launches our application. It is the top level. A mediator mediates. Models do work. Views subscribe to data. All right, so just to make things a little bit concrete, give you some examples. These are some models that I write and that we write in our actual applications. Just business logic was a little too vague for me. Root model. For me, when I write applications in this framework, there's some top-level model that is basically the arbiter and owner of all system resources. So if I start up my application and it talks to a valve block and some motors and a data acquisition card, that root model opens the references. It then might share them with launchees, but it's sort of the top-level system state process controller, something that's executing, doing some control logic. Sequencer process model, those words might sound a lot like test stand, but a lot of us.
So do you do dependency injection in your framework?
You're gonna really like the last slide.
Okay, and wait.
You can read the list. There's lots of kinds of models. Those are some examples. So, what does a clean view do? It displays, it presents controls, as in they're just on a front panel. Handle events thinly. Right? A thin client is a client that basically depends on data to be served. We try to keep as much logic out of these things as we can. So, the thin handling of an event, which is, I think I'm just made this term up. I don't know if this is proper use of the term, but would be I press a button and it makes sense for that button to get hidden or disabled. That's the UI behavior that I want, right? So if I press a button on a front panel, it's okay for that VI to hide that button after it caught the press. But it's not interpreting that press and sending some message off to a PID controller to tell it to initialize its gains and load something from. It's just dealing with the controls that it defines immediately. Right? There's an obvious performance benefit. If we want to disable something or hide it, we probably want to do that as soon as we can after the button press so it doesn't get double pressed, etc. We want to take analysis, calculations, control. My views should never have hardware resource references or cues to other actors or any nonsense like that. Okay. And then to further confuse things, we'll talk about the ViewModel real quick. Because when we want to do concrete work, we need some coupling. I can write really cool, beautiful views and really cool models, and if they don't ever interact with each other, my application's probably not going to do anything useful. So the ViewModel, I think the most interesting thing that it does is actually the last item on the list there, is that it receives events from this hierarchy of views that it launches. So if I press a button, the ViewModel decides that button press is the kind of thing that should be published to the bus, or maybe nudge the models into doing some kind of concrete work. And it does some silly top-level stuff like runtime menu, because the top-level window has the runtime menu. So ViewModel is the thing that gets launched first, everything gets nested under it, and it owns the top-level window properties, size, location, maximist, that kind of stuff. All right. So transitioning from theory and context into concreteness. Any questions so far? So why this Viewable? I've been talking about views, and I'm also going to transition into using the terminology of the framework, just to try to be consistent with myself. And if I show you code and I say this is iViewable, you don't say, is that a view? Oh, yes. Yes, it is. This was the way that I got into separation of concerns. I worked with John on some code years ago where he had written a cool abstraction for views, and we were popping them in and out of subpanels, and I thought, this is really cool. And then I took those ideas onto another project, and I started writing views that could own views, and I called them layouts, where I could have a view that was nothing but some subpanels. And then I could take these views, and because they had the ability to insert, I could insert them into the subpanel. And because that layout was also a view by inheritance, I could insert it into a subpanel. And I worked with that for quite a while without realizing the full implications of it. All right, so that's how I got into this. Now, there are common VI server things that we want to do, like I just mentioned: insert, remove, open, close, set properties of things that are on the screen. And because views display data, obviously they need to subscribe. I have a couple other classes that are members of this library with iViewable. One of them is called Protected Subpanel, because when we get into this world of dynamic views that can be popped in and requested in different places, how do we make sure we don't have insertion race conditions where I ask this view to insert and then someone else asks a view to insert and then they meet at the subpanel? Who wins? Well, the one who has, in my design, the one who wins is the one who has the most recent timestamp for insertion. So then the subpanel that they're getting inserted into decides. This one's newer than that one? Okay. If it gets a stale request, it ignores it because there's already a newer view installed. Views can handle events. I'll show you how that works. And system style. So this actually came out of interaction with a colleague who's using this for some implementation, and he's the kind of guy who will break it the moment you give it to him. The moment you give it to him, he finds something to do with it that you never thought of.
Yeah, yeah.
And I love him for that because it's really helped me make this better. So application style was, well, how would I set all my splitter bars recursively in my entire application to be the same color? Or things like that. It's a very simple abstraction. It takes in a VR server reference to a VI, and with that reference, you can do a heck of a lot of formatting stuff.
I was going to say damage.
Damage. Yes. So, you know, it's one of the things in the framework that I'm least proud of, but it works. So if you have ideas about how it could be better, I'd love to hear them. And if it really, really bothers you that it's there, I'm not beyond taking it out. Right, so Viewable is about the fattest interface or class in this framework. It does a good amount of stuff because, well, you know, when you want to have access to the different things that VI Server can do to a front panel, well, it's a lot of stuff. And I tried to expose the things that I use a lot, that are high value, and do it in an API that's easy to use. So a lot of these you do by message. So if you want to do something to a view can invoke a method statically on its diagram, or you could do it by message, sending a message to that view. So insert, open, close. Views also have the ability to launch a framework level dialog box, which can be launched with the modality of your choosing. And views can only launch one at a time. So there are some helpful things built into View. So views generate events. How does this work? Who's ever written an actor core event handler kind of like that? Just want you to exercise your arms a little bit. I found this extremely tedious, to the point that I wrote a script, and I had some AEs a few years ago write a script for me, or take some of the scripting that I had done and actually finish it, to just write this. Because I was so freaking sick of writing this VI, and even save as is just more work than I was willing to invest. But there's even a better way. So, part of writing this framework, I realized I heavily refactored the way that events work in the framework. And I landed here as something called Event Aggregator. Now in Labview, we don't have interfaces. Right? By the way, when I put an I in front of a class name, I'm notating that that's an interface. It's a programming naming convention that I learned from C#. That's what's happening. I should have mentioned that earlier.
And those are abstract classes?
Yeah, when I use that
High value classes, right?
Sometimes they're ancestor classes. Usually when I use the I designation, I keep them as abstract as I possibly can. They usually don't own data. They're basically providing a message interface to something else.
Yeah, okay, but what I mean is how do you implement them? Are they just the by value classes?
In this case, they're actors.
Oh, okay.
But I do have, I'd love to talk about by reference implementations. I think, actually I was talking to John and he said, this sounds a lot like what Dimitri does, not that long ago, so we can talk about that
Okay.
later. Right, so viewables are also event aggregators because views have bytes. And I was sick of writing that loop. So, I cannot write that anymore. But on top of that, right, every one of those passes data into actor core and then does some work with the data. And that requires every actor that handles events to define its own message set of actor framework messages that it sends to itself. And while I'd much rather actors send messages to themselves than to other actors around the tree, I still don't like it. I don't like managing all those messages and then realizing, oh, I need a refactor, and these 3 messages go away. It's just the tedium of cleaning all that up on disk and modifying message class data, even with the rescript, because it makes everything hideous again. I just wanted to get away from that. And who's ever put like coercions or range checking into that event handler? Because it's right there, and the event happens, and the event data comes into the event data node, and it's just so tempting to do some work in there. And then before you know it, you're putting methods in there, and you're basically creating a 2-headed monster where your actor core parent method is doing a lot of the work, but also there's a lot of work going on over here, and if you branch and wire that class data up to that loop, it's stale and utterly useless in most cases. So it's just all smelled a little fishy to me. When we're in the land of asynchronous dynamic programming, why do I have this static loop here that I have to go manually edit all the time? Especially when I'm doing the same things. So this is what event aggregators can do. They're actually launching an actor called Event Handler, which handles events. It's that loop that you just looked at, but one that has dynamic events defined for every possible event type. And when I make this little API call and I say register for control events, I can wire references into it. I can pick from any of the valid event types, and I can register multiple event types for those 3 controls, or 1, as I've done here. And now those event messages show up in parent actor core in framework messages that you don't have to write. You can unbundle the event data out of those messages using property nodes, because I created all the accesses for them. And I'm not wiring it there, but in the register for control events method, the one with the inputs going into it, you can also inject your own custom event filter reference. So it's another framework abstraction that lets you define custom filter events. And it's a by reference class. So when you open a reference to a filter and you wire it into that method, the filter data persists between all of the events. So if you're doing tree manipulation and you need your event handling cases to have awareness of other events that were fired in the same loop, no problem. And if you really wanted to, you could take that filter reference and wire it into your actor core. So now your actor core could, on the fly, modify the way that events get filtered in the event handler.
Ethan,
Yes.
just a quick question. When you say event aggregator in this context, you don't mean the event aggregator design pattern.
No,
This
I
is
don't.
a completely different thing.
So I'm not talking about the object-oriented design pattern event aggregator.
Okay.
At least I don't think I am.
I got confused.
I did want to say, though, that because we don't have interfaces where I can say my viewable implements the event aggregator interface, the only way I can get the behavior that I wanted for this framework was by doing it by inheritance. So my viewable descends from event aggregator, which gives it the ability to do this. My models, because models do business, don't have UIs and therefore don't have buttons to press, do not descend from event aggregator because none of it's relevant. And I found that I had to make very few compromises in terms of designing this using inheritance only. And I think that largely has to do with following the solid design principles as best I understand them when I could. Right, so I already spoiled this one a little bit. View Manager is the thing that I used to call layout. If I have these rules for inserting and removing and opening views, I can apply them recursively to any depth of nested views and basically not have to write any code once the framework is done. I might want to write those views, like the actual front panels with the subpanels in them, but there's not a lot of work to do there. Right? But another reason I want this is because the front panel resizing in Labview is not exactly the best, to say it mildly. Right? If you check that little box to resize everything on the front panel, you probably uncheck it about 3 minutes later after seeing how it actually works. So if you, but splitter bars work marvelously. Right? And in fact, I was showing this to someone else, a customer actually recently, who's sort of a programming generalist, and she said, "Oh, that's just how something." I don't remember what language she uses, but oh, that's just how this other language works. I said, "No, cool, anti-code smell." So who here has used splitters to divide up a UI, and then you can auto-scale the things and let the splitters define whether they stick to top, stick to bottom, left, right, size proportionally, all that. If you don't do that, learn how, because it's going to reinvigorate your enthusiasm for Labview user interfaces. All right. Because view managers own views, now all of a sudden we have the need to enforce some rules. Right? In the actor framework, there are rules like actors give their nesteds the key reference, and nesteds have the launchers. Viewables can launch, view managers can launch view managers, can launch view managers, etc., can launch views. And if you assemble this with dependency injection in your launcher, I'll show you that at the end because I don't think it makes sense until we get there, you don't have to write code for launching. You just assemble these things into the hierarchy that you want, and you launch one. Application style. So launching all of the viewable event aggregation stuff and application style, right? Those are recursively propagating downward. So because this hierarchy follows the same set of rules because they're all viewables, that just works. And value updates, relaying up, this is the first time I'm mentioning this, it's kind of the opposite. If I can have these nested views at any depth, and any one of them could have an emergency stop button, if I want that emergency stop button to actually get up to the view model to say, hey, emergency condition exists, I don't want to have to write messaging to traverse that tree. That would be a lot of messaging. And it also makes the views much less reusable. There's a rigidity to that messaging, especially when it's done explicitly.
But that rigidity is not in the view? Oh, you mean like of the views tree?
Yes.
Yeah. But it's true in general for actors if they use tree topology.
Yeah, if they use the direct messaging.
Yeah, no, direct is peer-to-peer. If you need to go
Okay.
over
Okay.
to the root, yeah.
If they need to talk to their launchers, right? So, what is the proper term for that? Does anyone know?
Hierarchical.
Hierarchical, yeah. So if I had I'd have to write this hierarchical messaging API for these things that are nested somewhere down below to communicate up to the top.
That's actually a potential violation of single responsibility principle.
Yeah,
It's
I
a
don't like
second
it.
reason to change for end class.
As you'll see, I don't like it either. So,
Yeah, I see.
um,
We're pretty much in the same boat.
just some quick examples of view managers. I made the splitters black so you can see them, but you want a 4-app test interface that's running 4 ducts at the same time. You want 8, 16, whatever. Write it. Just put some subpanels in there. A tab view manager. How frustrating is it when you're dealing with doing the old trick in Labview of making a tab structure transparent and then hiding the tabs or showing them and trying to switch through the tabs and populate different things, but also have that UI scale. Right? The tab structure will scale, nothing in it will scale. It's kind of useless. So with this, there's a subpanel and a tab structure across the top. You press the tab and the view manager populates the view in. And it's totally configurable at runtime. You can name those tabs anything you want. You can have more or fewer. Or something like this. If you've ever used Labview, you've seen a window like this when you open Tools Options, for instance, and you have a selection list on the left, and whatever you click on, stuff populates into the right side. By the way, these 3 examples and more are just in the framework as concrete extensions to the framework. So I guess I consider them framework because they ship or install with it, but they're not actually part of the abstractions. Right, so all of a sudden we have design by composition for UIs. If I want to move these pieces around, I can do that, and I'll show you. But this means that I need event routing up the hierarchy, because if I take this view here and I move it under that view, which becomes a view manager or something, I don't actually want to change the meaning of any of the button presses in that view, and I don't want its subscription behavior to be any different. I just want to look at it differently. It's organized differently. So here's the example that I mentioned earlier. If we do this from nested to launcher, the old-fashioned way, I have to write messaging between those. And Alan pointed out a way in his presentation that we could do this with pre-addressed messages and by defining an abstract message library for messages that don't have data. If I send an e-stop message, I don't necessarily need data in that, right? So maybe I can cut some corners, and I don't mean that in a negative way, but maybe I can save myself some development effort and duplication of work. But in the MBA framework, you don't need to do any of that, because when I register for an event in buttons and I press e-stop, because I've satisfied the contract of these all being viewables, and I must have because I launched this and it's running, that e-stop just arrives at the top level view manager, who relays it to the view model, who then says, what just happened? Oh, emergency stop. That means model stop, or model shutdown, or model safe state, or whatever. The view model, the top level actor, decides what to do with that, but I don't have to write any of the messaging to get it up there. All right, so there's not a whole lot to say about models because they're application specific. I don't know what you're trying to do, and even if I did, I probably couldn't write it all into a framework, because the framework would solve every possible software problem in the world. We'll leave that to Google or something. But there are some basic expectations for models. They can publish and subscribe, because they might need data to do work, and they definitely want to publish some results, whatever that means, chart data or something. And they can launch nested models. There are 2 ways I can launch nested models. And I'm not thrilled with the verbiage that I settled on, but I haven't yet thought of anything better. Explicit means I launch it basically like an actor. You know, it is absolutely an actor of the actor framework, but if I want to do something with its queue reference, that launch returns the queue reference, and I can store it, and I can send it special messages, whatever. Mediated means this actor is maybe what you called, Alan, an ephemeral actor, something like that. I might launch an actor that just goes to a config file, reads everything in the file, and publishes it to the mediator bus. That actor is done running as soon as that task is complete, and I don't need its queue reference, and I don't need to give it anything. Right? If I can just launch a business actor, a model, and I don't need to tell it specific commands, and I just need to know that it ran without error, I can launch it as a mediated or nested, I guess I called it mediated, and then the framework handles everything. The one thing you should know about all of this contractual stuff, when a view gets launched, when a model gets launched, they get launched with pre-addressed messages that let them publish and subscribe, or in the case of views, just subscribe to the mediator. So they don't have to traverse the tree. Because they are who they are, they have certain permissions, and that's what lets these nested models just launch. And I don't have to write any code to handle that. And yeah, they can publish. Okay, so I already said that we need to write a view model, right? It couples these two domains together. It owns some top-level stuff. And it ultimately owns, in the classic actor sense, the mediator, the hierarchy of models by having the reference to the root model, the hierarchy of views by holding the reference to the root view, and the top-level window properties. So I added to the framework a publish ViewModel data, but you could just publish because you have the mediator's queue too. I just thought it was one less, or 1,000 less callings of read or unbundle by name to get that queue reference, and it's just wrapped up into one tidy little thing. So behaviorally, this is how it works. And I've tried to use the actual API names in this chart. Models can publish. Viewables do not directly publish. You press buttons, those button events will get caught if you let them by the view model, and then the view model can decide if that is something that needs to be published or not. And maybe you're typing in set points. Clearly those need to get to the model somehow, right? So you could send them by message, or you can publish them to the bus. It depends what the model's expecting. It depends how you want to design your application. View model is the gateway for viewables to publish. We recently changed this so that anyone can request synchronous data. So models, views, and view models are all observers in this design. So they can request asynchronous message, which is abstract actor framework messaging. So you can say, I want the datum named set point, and it's a double floating point, and give it to me in this message. So when an actor gets that publication from the mediator, it doesn't only get the data, but it gets it with the message that invokes the work that it wants to do with the data. Request data originally started out as a hack, if I'm being honest. I said, I just don't want to write all these abstract messages right now. So I'm going to create an overridable method in the observer class called observe data, and I'm going to have one framework level message called request data, I think. And any observer can say, I want that double set point, requesting it by name and type, and then the mediator fulfills that request with the framework level message. And when that actor catches it, it invokes observe data. So I can now take that, cast it to the type I know it must be because I requested it by name and type. So there's an implicit type safety in this solution. Observer can't, if an observer requests a datum that doesn't exist, it's not going to get anything. And if it requests it something that doesn't exist because it's got the wrong type, it's still not going to get anything, bless you. So I'll show you how that works. And request synchronous data, because sometimes, despite all of this striving toward asynchronousness, we still need synchronous behavior. If I'm launching a test step, and that test step, the first thing that it does is turn the motor on at some velocity, and I don't know that velocity yet, I can't really do anything.
Yeah, so those are implemented as blocking calls.
Yes.
What about deadlocks?
Hey, you can program deadlocks into any bad code. Yeah. I mean,
It would be easier to do it with this.
easier to deadlock?
Yeah.
Can you give me an example of why it would be easier to deadlock with this compared
Let's
to?
put it offline.
Okay. No, I mean, there was a reason that it was only models could request synchronously, because I thought views never need to have this ability. I don't like it, but I found myself using it once in a while. And John came up with an interesting use case recently. He's smirking. John's the one who made me move it.
So this is essentially a get value message, right?
Yeah, so this is when you're
So
launching an
that's,
actor.
Getting values.
You're launching an actor, and it, rather than subscribing to data and then just going about its asynchronous business, it sits there and waits at that VI until that subscription is. Oh, but there's a timeout. So, I mean, you don't always. If you program
And you
poorly,
do it in the message loop.
I mean, you could loop the synchronous request.
I mean, wouldn't it block your actor core from doing other stuff?
Yes, but the thinking is that a model that's doing a synchronous request is doing that for a very good reason.
It's in the idle.
It might be doing it in pre-launch init. In fact, that's the way I would prefer to use it, is in pre-launch. That's where I use it.
Okay, pre-launch, I understand.
Okay, cool.
Dodge. Bullet dodge.
So models don't generate events. Viewables can generate them because they have buttons. They can catch them from their nesteds. So if someone pressed e-stop down there, okay, pass it up. View models generate, catch, and publish rather than relay, right? They can't relay because there's no one above them. They can either decide to discard it, or they can decide to publish it to the bus. Or they can interpret it as something that requires invoking action of the model, and they can do that too. Yes. There's only one. Okay, let's talk a little bit about mediation. How much time do I have? Oh, 20. Yeah. So I'm not going to say much about this. When I designed this mediator, I was concerned with type safety. So the requests are by name and type. So when a viewable subscribes or a model subscribes, they say, give me the cluster of this type named settings. I can't get back the wrong thing because the mediator checks the type before it fulfills the subscription. Jitter. I want to make sure that when I'm publishing chart data or streaming data of some kind, that it performs well, that it's not choppy, right? Endpoint to endpoint transit time. I've got some tests, some benchmarking tests, which I actually just run as part of my unit test suite. That launches 10,000 actors and tries to put 100,000 samples through the pipeline as fast as it can. It's just a sanity check for me to make sure that if I change the way something works under the hood, that I haven't broken it. It definitely saved me early on when I changed something to be from actor-based to by reference, and I didn't do it right. And robustness to improper use. So when I publish stuff to the mediator, or subscribe, if I make stupid requests of the mediator, I can't make it crash. Because if the mediator can crash because you don't treat it right, that's a major fragility in my application. It's not cool. So those are the things I thought about. And if you don't like my mediator, but you like everything else about this, it's well-defined in an interface class that's totally abstract, so feel free to write your own and make it work however you want.
Is it an actor or by value class?
It's an actor.
Does it have to be an actor? It receives messages?
In this framework, yes.
Okay.
It does have to be an actor, was Dimitri's question. So, talking about design by composition, something that I was using early on before I got to framework level was transport abstraction. I want to transport data from here to here. That's a pretty nebulous thing. I could use a queue, but maybe the data I want to transmit is a string, and its ultimate destination is the caption of a control. I can use VI server to do that. I'm transporting information from here to here. So I've got all these transport types. Super simple interface. Write data. You can put data into it as a variant, and it'll try to write. If the write fails because I asked it to do something stupid, the mediator will just say, this is not a good transport, and therefore its subscription is invalid, and it will just remove it from the list. Subscription policy. I thought really hard about this one. And I was hung up on the idea that, well, there's performance implications of publishing a ton of junk I don't need. If I'm sampling at 10 kilohertz and I just want to chart some trend data, why should I transmit all of that from publisher to subscriber and then have the subscriber discard most of it? Right? So that was sort of the first thought that led me in this direction. But it opened up a whole set of interesting possibilities, I think, interesting, where I can subscribe basic. I just want everything. Just basic subscription. If you publish it, I want it. Value changes for things that aren't charting, basically. Anytime I want value updates, but I only care that the screen's showing the latest value, we can save on a bunch of transmissions by only receiving value changes. One shot, maybe I'm doing some localization or something, and I just want to read some strings from the bus and write them somewhere, and then I'm never going to call that again in the lifespan of this application. I don't need to unsubscribe. I can just do a one-shot subscription. So, triggered. Publish the values when it's greater than 0. That's the idea of policy. It's a by-reference class. You inject it into your subscription request when you make it. But in most cases, you don't need to do that because the most commonly used subscription styles are already defined in a nice, tidy little subscribe API that belongs to viewables. So I can bind a value. I can bind a caption to a string. I can bind multiple values. I can bind the Boolean text of a button. I had a customer ask me to put the cycle count on the button. And I was like, oh man, I got to write all this code to do this. And I realized, oh, I can just create a binding type or transport type and then wrap it up here, and now I'll never have to write that again if anyone asks it before it. I can bind the visible state of something to a Boolean publication on the bus. And all of a sudden, my views are doing extremely useful things, and I'm not even writing any code to do it, and it's all driven by mediated data behavior. So what does it look like when I actually put my application together? It looks like dependency injection. This is an entire application where I'm assembling an application of a view model, a view manager that's got a couple panes. I'm nesting some views under it. I'm launching my example model, and then I'm launching a mediator. And into that mediator, I'm injecting a mediator bus monitor, which is a concrete debug window. If you've ever used MGI's monitor actor, it's the same kind of idea, right? I can see the entire state of what's running. But in this case, I'm observing the state of the mediated data bus. And then I call launch root actor. That's just the launch root actor of the actor framework. And then because my ViewModel is my top level actor and it owns front panel states, I open it by calling the viewable open front panel. I have officially no time for a demonstration, but I think you probably want to see some running code. I know I'd like to show you.
Wait, step back.
Oh, yeah, you want to see that? You can also come talk to me. I won't bite you. Slowest draw on the list. How do I get this off the screen? There we go. All right, so I recently added, long overdue, some simple examples of how to use this with comments. The code itself is very well commented. It's very clean. So if you open it up and look, I think you'll be able to trace your way through it if you're reasonably well versed in the use of the actor framework. So this is basically a template. I'm just launching a bunch of abstract stuff with a concrete mediator. And if I run this, you can see I get nothing. But the cool thing is there's no code written for this. It's just all framework stuff, but it shuts down and it runs. It's not very exciting though. I can launch a chart, view model, viewable chart, a model. I'm injecting a little configuration in here, and you'll, well, because if I don't, the model won't run. Here I have a chart. Chart's inserted into the view model. It resizes as well. My goal here was to build up gradually so that if you could open one of these and understand it, you could move to the next one. Yeah.
Do you handle the defer panel updates, being that it is a...
So there's a tree. So the question is about how do I handle defer panel updates? A lot of the messages to viewables can be propagated recursively down. So if you want to defer updates in a hierarchy, you could do that by sending a message.
I mean, I do that by like increment. It's almost like a memory, you know, like the way you do memory management, where you increment the counter, like when you want to defer, and decrement the counter when you want to defer, and then the top level, when it, you know, when the counter is 0, basically stops deferring, because you really can't control who sends you defer and undefer.
Well, the framework can control who.
I don't want to sidetrack you now because you're got like 2 minutes, but we can talk offline.
Okay, sounds good. Okay, so I'm adding a slider to my chart. All I'm doing here, and then I think this is the one you saw up on the screen earlier, is I created a 2-pane view manager that basically defines these 2 subpanels, and then that's about it. It writes them where the subpanel references need to be, and now I can inject these things into it and launch them. And there's a not so secret slider over here that I probably should have disabled, but you can see that I can change the size of this and it just works for both of the controls. And I can change the speed of publication. And I think this is where things maybe get interesting because I can show you how this stuff propagates through the framework, although I'm kind of out of time. So 2 minutes, okay. So let's look at how it works. I have a viewable called vertical slide. It has an actor core. It looks like this. It's a vertical slide. It's registered for the value change of data rate. All right? And as I already mentioned, when I call this register for controlled events, this core launches because it's an event aggregator, an event handler that handles this event. Notice vertical slide's not handling that event because by default, viewables relay their event data up to the view model. So the view model catches a nested value update. How do I publish this one? I got lost on my own example. Oh, no. Oh, okay. Quick recovery. By default, the view model publishes everything it receives. And as I note below, reasonable behavior in many cases. It doesn't mean you always want to do that. Okay. I'm going to show you the complete cycle and then I'm done. So the view model catches it, it publishes it to the mediator bus, and then the model, my simple root model, in pre-launch init, asked for data rate by calling request data, and then it uses the observed data override to catch data rate, cast it to to a type it knows it must be, because it requested it as a double, and puts it on the class wire, and now it can update at that rate. So, come with questions, come with comments, and I'd love to talk to other enthusiastic people about this stuff. Oops, not source tree. So, thank you very much for your participation.